Hi everybody, hope you're having an amazing VMworld so far. Today in this session we will have Gabe and me share new updates about vSphere 6 for vMotion. So we will first go through the architecture, the features, and then go into debugging and performance. Let's get started. All right, that works. So disclaimer, standard stuff, we will be sharing a lot of things that are more future looking, and they may not be planned even though we mentioned here. So we just try, it's a standard disclaimer. Hopefully you have all been through it. The agenda for today, we will have three main sections. The first one would be about the features. So Gabe and I would be on stage sharing different aspects about it. We will then open up for a few questions just because we'll be ending that particular section. So any questions related to that, I would love to answer those. Then we will move on to the vMotion performance and debugging. And finally, we will share some new things forward-looking that we are planning for the future. Okay, before we get started, I was hoping to share two themes that have kind of driven vMotion in general, but in specific here, one being your feedback. Customer feedback is very, very important to us, and we take it very seriously, even especially in the vMotion team. And you'll see through it, while I go through the deck, you will see where all it has become so critical to us that it has driven the definition for vMotion a lot of times. The second theme, I'll talk about it towards the end when we are in the futures section. And there's something new that we want to talk about. And again, there as well, we would love to hear some feedback from you folk. All right, so some history about vMotion. We launched vMotion with vCenter 1.0 a long, long time ago, and I'm sure you all remember. At that point, it was just about migrating compute resource, migrating from one compute resource to the other. It was pretty cool back then, but we never stopped at that point. The next we did was in 2.5 with storage vMotion, which is where you could migrate from one data store to the other data store while compute resource still resided on the same machine. And then we did the multi-NIC vMotion. This was pretty cool because you could now do much faster vMotion. We basically expanded the bandwidth available to you so that you could vMotion much, much quicker. And then the second aspect about this version was the stung during page send. So all the fast VMs you had, which had a very high memory page dirty rate, you could now do that as well. The fourth thing was about vMotion without shared storage. Now at this point, you could simultaneously migrate both compute and storage. This was huge. And we got amazing feedback from you folk as well, and it was really nice to be in the team that has done this vMotion possible. And finally, you would know the recent version, we had vPlex Metro support and IPv6 support improvements, which was basically performance improvements that helped you utilize a lot of things that are up and coming. So we've done all of this, and it's really cool to see what next, and that's the theme. The second aspect of the theme that I wanted to talk about was about the fact of doing vMotion anywhere. Now that's a goal our team internally has, and we'll get to it at some point. Hopefully there are a few new things right now that we're looking at which kind of translates into reality. But let's talk about what's new now. Now, vSphere 6.0 is the fastest adoption release in the history of vSphere. That's amazing. But what gives a kick to us internally is about 73% of you told us that it's because of vMotion improvements or vMotion enhancements. Now, this is amazing for us, and that's why, again, I wanted to tell you that, tell us the feedback that after you use vMotion, and we'll make sure that we incorporate that in the next release or future editions. All right. So the 5 new features, we're going to highlight about the 5 new features in vSphere 6. We'll start at a stage wherein, at the point wherein we are able to do changing compute as well as storage simultaneously. So the first thing we decided to do was vMotion across switching boundaries. So now you can go about from one distributed switch to another distributed switch, and that's pretty cool. But we didn't stop there. We went ahead and did 2 amazing things. The first one was vMotion across networking boundaries. So you can do it across L3 networks now, and then vMotion across management boundaries. Now, what is management boundaries here is I'm referring to vCenter specifically. So you can now migrate from one vCenter to the other. But this was just, these three were the building blocks. What we really wanted to do was vMotion across geographical boundaries. Yes, that's right. You can now vMotion from one part of the world to the other part of the world. It's really cool for us as well to internally to have all this trajectory to eventually reach a goal that you always wanted to do. And you can see that it's part of the theme that I was telling you about before, was vMotion anywhere. So here is where we've reached at one point, and I'll tell you towards the end, future looking, what new we've planned, and I'm sure you would have heard about it in the keynote, but again, we'll touch on it a bit later. But then again, we didn't stop there. We know that a lot of you have a replication story in your environment, and it would definitely make sense to have a replication-assisted vMotion. So that's the fifth feature we would be talking about today. And I would like to invite Gabe next to dive deeper into the first few of those features.
Thanks. All right, so Nakul introduced the kind of vMotion Anywhere vision, which is where we want you to be able to migrate your workloads from whatever infrastructure you have and whatever site you have to whatever remote sites or remote infrastructure you might also have. I'm just curious, how many of you saw the vMotion to the cloud demo? I think it was yesterday morning in the keynote. Show of hands. Okay, about half of you. I would have expected a lot more, actually, given that it was just the keynote. But personally, I thought vMotion to the cloud is pretty awesome. I mean, that just demonstrates what we mean when we say vMotion anywhere. Like, you've got a VM running on-prem, you want to migrate to the cloud? No problem. Back? No problem. That's the vision. So we're trying to take you there, and here are some steps along the way. So in particular, let's say you've got a site in, say, California and maybe one in London. You want to be able to vMotion between those sites. Well, in 6.0, you can. We've expanded our round-trip time vMotion network support from 10 milliseconds, where it was with Metro vMotion, up to 150 milliseconds for long distance. So 150 millisecond does work out to be about the latency between California and London. Now, getting to 150 millisecond round-trip time is actually a lot of engineering work, and there's a lot of depth here that I'm not necessarily going to talk through in great detail unless people are interested, and by all means, feel free to ask me questions. This was a lot of work, and there's a lot of interesting stuff to talk about here. But suffice it to say, our primary concern was about performance. At the end of the day, vMotion is important and useful to you guys because it means you can migrate a VM without having to take downtime for that particular VM. I mean, you need to do host maintenance, you move the VM off of the host. You don't have to worry about the migrating VM's performance suffering, right? And that's critical. So as part of supporting long-distance vMotion, it was really important to us to be able to maintain our standard vMotion network guarantees, or standard vMotion performance guarantees, even as bandwidth decays or as latency increases, right? So a lot of work there, a lot of interesting stuff there. Now, like I said, I don't necessarily want to get into all the details, but there was a lot of work done to ensure that the vMotion performance maintains its, let's say, well, so vMotion, one of the major aspects of vMotion that is important to understand is there are three phases, right? There's iterative precopy, there's switchover, and then switchover in turn can be decomposed into stunning the source and resuming the destination, right? End to end, that's really the performance critical part of vMotion because that's the part that really determines the guest impact of vMotion. So one of the major things we had to focus on was ensuring that as latency increases, the round trips between those two remote sites don't impact performance, which in turn means we have to do things like minimize round trips between hosts, try to batch RPCs so that the source host and destination host don't have all these round trips bouncing back and forth over this high latency network. A lot of depth there. Similarly, if you look at the way New Reno with vanilla TCP congestion control works in the presence of high latency, you can see things like packet loss can cause really severe bandwidth decay issues because you can get stuck in, say, congestion avoidance or slow start if you see some packet loss. So we've done a lot of work to improve the network stack in general for ESX, for management network traffic and vMotion network traffic to be less, shall we say, harmed by occasional packet loss. So the work here is primarily about switching from the vanilla New Reno congestion control to something like HSTCP or high-speed TCP, where you can tolerate some packet loss without switching to slow start, or switching to congestion control, congestion avoidance. Okay, so that's a lot of random things about long-distance vMotion and just kind of a lot of the different genres of things we had to deal with to make long-distance vMotion work and maintain high performance. And we'll dive into some of the performance a little bit later, but at the end of the day, the important thing to understand is that vMotion just works, right? As bandwidth potentially decreases at your higher latency, and as bandwidth decreases and latency increases, we can still maintain the same performance you know and love today, right? One thing to note about vMotion network bandwidth is that we do maintain our same requirements that we have today, which is at least 250 megabits per second of network connectivity per concurrent migration. So if you want to do that vMotion from California to London or the like, you'll need to provision at least 250 megabits dedicated bandwidth per migration. So 4 concurrent migrations, you're talking ideally a 1 gig link between those data centers. Whether that's feasible or not depends on your environment, but our same requirements exist that have historically. Okay, so long-distance vMotion is here, but what does that mean? There's a lot of implications of the fact that you can do a long-distance vMotion. Now, in particular, you're vMotioning your VMs between different sites, right? And that implies many changes that aren't necessarily something you have to worry about today. In particular, today, when you have a site, say you're vMotioning within your California data center, it's feasible to put all of your hosts on the same vMotion network L2, right, the same subnet. That's not such a big deal. It's annoying, yes, but you can do it. But as soon as you start talking about vMotioning between, again, the different sites, California and London, it's not so feasible or practical to have your vMotion network entirely spanning one single L2. I mean, it could be done, but that's painful. So we're instead now allowing you to have your vMotion VMKNICs on different L2s or different subnets. Right? And we're doing this by exposing a new concept called a network stack. The idea behind a network stack in vMotion is that you can configure, for example, a vMotion network stack that has a vMotion-specific default gateway. Right? Now, historically, if you look at vSphere 5.5 or the like, when you configured networking on an ESX host, you could only configure one default gateway. Right? And typically, that would be the default gateway for your management stack, just because by necessity, you needed to be able to route your management traffic. So we had to configure the ability to expose also a vMotion default gateway. Right? So that's what having the separate vMotion network stack allows you to do. You can specify a vMotion-specific default gateway. This is interesting and, again, implies other subtle interactions with other layers of the system. So if you look at a cluster today, DRS is doing vMotions between all of the hosts in your cluster. One of the key assumptions about a cluster, in fact, is that you can vMotion a VM between any host within that cluster. So it's critical that all hosts be able to reach all other hosts in a given cluster over the vMotion network, which means, in turn, if you're going to configure vMotion over L3, that is routed vMotion traffic, you have to configure that on all the hosts in a given cluster. You can't mix and match vMotion over L2 with vMotion over L3, because the vMotion over L2 hosts, the hosts that are assuming they're in the same subnet, won't be able to reach the hosts that are in a different subnet. So you really have to change all the hosts in a given cluster to either be routed vMotion traffic or same subnet vMotion traffic. It's important to realize that just because vMotion now supports routing its traffic with its own default gateway, we still have existing features that don't. In particular, if you look at FT, our fault-tolerant solution does require still that you have same L2 adjacency for the FT network. And along similar lines, if you're using DPM, Wake on LAN requires that you are in the same L2 unless you support directed subnet broadcast. So that depends on your environment, but you may or may not still need to worry about some L2 adjacency issues there. Okay, so let me hand it back to Nakul, who will talk about some other interesting features and implications.
Yeah. So what if you have ESX hosts which are across different subnets? We talked about vMotion across switches. You're all aware that there are two kinds of switches: the vSphere standard switch and the distributed switch. Now, with vMotion 6, we do support migration across from VSS to VSS, from VDS to VDS, but also from the fact that VSS to VDS. So these are the three different things that we do support now. All the parameters that you have or all the rules that you have on a virtual machine would exist and are preserved when you migrate it as well. The one caveat here is that vMotion across from VDS to VSS is not supported still. This is primarily because the fact that these are inherently very different switches, and standard switch does not have all the capabilities that a distributed switch has. So a virtual machine may not have all the rules that are applied to a VM when it's migrated from a distributed switch to a standard switch, cannot be maintained. And that's why we don't support that migration. The next one is about across vCenters. Now, say suppose you have two different vCenters and have hosts under these two different vCenters. Now, what happens is the fact that for now, or before this, you were not able to migrate a virtual machine from one host or one vCenter to the other vCenter. But with vSphere 6, you can do that. You can migrate across with compute, storage, networks, and vCenters. Now, what happens here is that a host speaks to the vCenter, which then communicates with the other vCenter, and then which has all the properties of the virtual machine after it's migrated, spoken to the host after that. So that's how the migration works there. It works with local, metro, as well as the long-distance vMotion. All your VM UUIDs are preserved, all the historical data. Everything else exists as is was on the host. It exists on the destination as well. We do have HA and DRS properties preserved as well. And finally, the aspect about SSO domain. Now, imagine you have both vCenters in the same SSO domain. In that scenario, you can operate using the web client. But if, say, suppose both the vCenters are not in the same SSO domain, we will support APIs. So we will have API support for that migration. But yeah, in case it's in the same SSO domain, then you can just use the web client and do the migration. It's that simple. Finally, as I spoke before, you do have the replication. If you do have a replication story in your data center, then you can utilize replication-assisted vMotion. Now, why do that? We all know that data copy takes the majority of the time while migration. And if you already have a replica on a destination host, then why migrate the data again? It's just not inefficient. It's just inefficient. So we do have vMotion across active asynchronous storage replication. Now, there are two things that I was hoping to highlight here was we do need VVOLs as underlying data store while doing this. And the second aspect was we do need to switch to sync mode while migration and then switch it back. So why vVOL? Now, the thing here is that you all know that LUN is the basic unit of data store. And what happens in disks that are stored, so disks are like a file on VMFS which sits on a LUN in regular data stores. So what happens when you migrate to a destination, it's very difficult to promote the LUN as a destination VM when the migration happens. But with vVOL, the minimum unit of control that you have, the granularity of control we have is with VMs. VM level control, and that's why you can, once you migrate, the disks can be promoted as a VM disk on the destination host as well. With regards to switching to a sync mode, what happens is if you have asynchronous replication existing, the destination host may not have all the disk up to date compared to the host. So we do switch while migrating to sync so that both the disks are updated, and then we do the migration so that you don't face any issues in case the host goes down or any other issues that happen. You will have an up-to-date disk on the destination as well. So those are two caveats about the asynchronous storage replication support for vMotion. And finally, to bring all the story in, I would like to call Gabe again.
Thanks. So long-distance vMotion implies lots of very interesting things, right? I mean, as we said, this was really the journey to vMotion anywhere, right? So along the way, with something like long-distance vMotion, you have to be able to vMotion across vSwitches, right? Because a DVS can only span a single vCenter. So if you're vMotioning across different sites, you're vMotioning across different vCenters, different switches, certainly across vMotion network L3s. All of these things come into play, right? And all of these things are supported in vSphere 6.0. Now, there's been a lot of work to try to, as I mentioned earlier, ensure performance is reliable. It's the same sort of performance you know and love from vMotion today. Next section is really going to dive into performance and understanding how these new features and functionalities impact your environment and the sort of things you should worry about going forward, if anything, and using vMotion over higher latencies, lower bandwidth links. So before we get to that, though, since we've covered a lot of different areas, and there's actually a lot of depth that we didn't cover here, are there any questions about any of these topics, or in general, vMotion? I mean, been working on this stuff for around a decade now, so if there's any vMotion-specific questions you have, I can take a few now, and we'll have more later. But for now, there should be mics coming around somewhere. Yes. So.
Hello. Actually, I have a question about the multiple gateways.
Okay.
Does this mean you can have a single gateway on every VMK port you curate now?
No, you can't specify a default gateway per VMK-NIC, but you can specify a default gateway per network stack. And the network stack is the encapsulation where you can put a default gateway, and then you associate VMK-NICs with that network stack.
Right, thanks.
Sure. There's one over there.
I was just wondering if the maximum number of concurrent vMotions has changed in 6. It used to be 4 and 8 on 1 and 10 gig links.
Yeah. Okay,
Anything
so those
different
numbers haven't changed. Those numbers are actually really, really interesting and possibly deserving of an entire talk in and of themselves. But at the end of the day, our goal with vMotion is, as I've said many times now, to ensure VM performance is not impacted, right? And if you think about the way vMotion works, it's iterative precopy and then switch over, right? The more bandwidth you give to iterative precopy, the faster we can migrate your VM. And the longer it spends in iterative precopy, the longer it spends with all of its memory write traced, and with all of that memory subsequently changing and being copied over the network. Meaning less bandwidth implies the migration will take far longer, right? It actually decays far worse than linear. It's not exponential, but it's still pretty bad. So it's important to understand that when possible, you actually want to do fewer migrations. If you do fewer migrations, they'll actually complete net faster than if you did them all concurrently. Kind of like, I don't know how many of you have tried this, but like if you just have a single disk and you do 1 file copy, that's pretty good. 2 file copies, okay, that might be better. More than that, you're just going to start thrashing and randomly seeking, assuming a spinning magnetic disk. Performance decays, right? With vMotion, you actually want to do fewer, and as such, we haven't gone out of our way to try to revisit those limits, because really, we'd prefer in the normal case you do fewer, not more, right? So I hope that helps. All right, let's do one more and then continue. Sorry.
Is it still going to be one interface per host, or can you define 2 stacks, one L3 stack and one L2 stack? I can imagine that you would like to have a 10 gig or higher interface for your local vMotions, and for your remote vMotions, you don't require that bandwidth.
Okay, yeah, that makes sense. As of today, there's no way to differentiate between different classes of vMotion and say, this particular long-distance vMotion should use this NIC, and this other one should use whatever, this particular gateway. That's a really interesting point, though. I can see how you might want to say, I have one gig NIC here, and I want to dedicate that to long distance, and I have a 40 gig here, NIC here, then I want to dedicate that to my local data center migration. You can't do that today, but that's an interesting point and something we'd be potentially interested in looking at. I kind of want to understand some of the use cases there, so it might be worthwhile just us syncing up after the fact, but point taken. All right, so let's keep going. So performance. One of the other big things we've looked at pretty much every single release of vSphere is trying to improve performance, right? Because I've said it many times now, but at the end of the day, vMotion is all about performance. It only matters if it doesn't impact your workload, right? So what if, in particular, you have, say, 40 gig NICs in your data center, right? Can we actually saturate 40 gig networks with vMotion? Well, there's been a lot of work in 6.0 to try to optimize for higher network connectivity between your hosts. Again, there's a lot of depth here. I don't want to spend a lot of time going into it unless folks are interested, in which case, by all means, there's lots of stuff to talk about here. But the key things we've been doing is to try to optimize the vMotion transmit and receive stacks to be more parallel, right? To take locking out of those paths, to ensure that the more cores you have, you can leverage those. We can now spin up additional send and receive helpers per your different NICs. If you've got, say, multiple 10 gig NICs, you can have a single vMotion helper per 10 gig NIC, and those work in parallel. Previously, they would end up getting bottlenecked on some internal locking on, say, VM memory page state. You have to have conflicting locks between these different threads. So there was some scalability issues there, and in optimizing for 40 gig NICs in particular, we really had to address those. There's been a lot of interesting work here, and there'll be some data on that coming up. Along similar lines, I briefly mentioned there's this vMotion switchover, right? vMotion switchover is where you stop running on the source VM, start running on the destination. Necessarily, that implies temporarily not running your guest workload because you have to actually switch to working on the destination, right? So there's been a lot of work to improve switchover performance. Switchover typically takes less than a second. That's how we try to ensure that there's no guest level observed performance impact from vMotion. So one of the things we've been doing is, for example, ensuring that we don't do any per-page metadata updates during switchover. In 6.0, we finally eliminated all of them. In 5.5, I believe there was a per-page metadata update we had to perform on the restore path, meaning if you had, say, a 2 terabyte VM, or rather compared performance between a 1 terabyte VM migrating and a 2 terabyte VM migrating, you'd see switchover time was slightly worse with a 2 terabyte VM. It actually was linearly worse. But now that linear scaling with memory size has gone entirely. So it's these sort of things we've been doing in 6.0 to try to optimize for kind of large-scale performance, both over network and VM size. So let's take a look at some performance data. When looking at vMotion, it's important to reason about total migration time, switchover time, guest impact, and vMotion network bandwidth. So with that in mind, let's start by looking at migration of a very large VM, right? Well, actually, no, reasonably large, not huge, but we support multiple terabyte VMs at this point. This VM in particular is a 512 gig VM. It's running a synthetic Redis workload, a set workload. The idea here is that it's a reasonably large VM and it's very active, right? So let's quantify the sort of performance we see while migrating such an active large VM. So if you look at vMotion network bandwidth we achieve, comparing 5.5 and 6.0, at 10 and 20 gig throughput, 5.5 and 6.0 are more or less neck and neck, not a big difference. Once you start looking at 40 gig or 60 gig NIC throughput, though, there's a pretty dramatic difference in that with 5.5, you got bottlenecked more or less at 20 gig, because that's what we optimized for at the time, and that's what we achieve. Okay. You could, in theory, tune 5.5 to improve performance. There are ways to increase the number of helpers, threads that help the send and receive process in vMotion. It's not recommended. If you really need to get that extra performance out of 5.5, we can help you do that. But 6.0 out of the box just works. It doesn't quite hit line rate with with the 60 gig NIC, but it gets close, right? And so we're continually trying to optimize that and improve that. But with 6.0, we are almost able to saturate a 60 gig NIC, which we're pretty excited about. Now, this is actually a rather subtle and interesting slide with a lot of depth to it. This is looking at achieved vMotion peak bandwidth as the intensity of a VM's workload changes. So I've mentioned that vMotion is built on top of this idea of iterative pre-copy, right? You're actually moving a VM by copying its state iteratively from the source to destination. This has many interesting implications when you look at peak network throughput, particularly comparing an idle VM and a very active VM. So if you look at the idle VM, we get a little bit over 20 gigs throughput, which is respectable, but not phenomenal when you have a 60 gig NIC environment. The interesting thing to note is that an implication of using iterative precopy is that as you're copying that VM's memory state from source to destination, you are allocating that VM memory at the destination as you receive it. Right? That's just how precopy works today. Which means if you're only moving an idle VM, a VM that's not doing much, it's not changing memory state, there's not a whole lot of memory changes to subsequently copy iteratively, you may only have one precopy iteration, right? You might just copy all memory from source to destination and switch over. That might be your entire vMotion. But if the VM's actively running, you can have multiple iterations of precopy, meaning you do one full pass, then you send the delta relative to the first pass and the delta relative to that pass. So that first pass copy is where we actually do all of the memory allocation in line. So you'll see when you're moving an idle VM, peak bandwidth is relatively low because we end up being throttled on page allocation. But when you move a really big active VM, performance improves because we get to the point where we not just do the first pass precopy, we do a subsequent pass and a pass after that, where bandwidth improves because the pages are there. They don't have to be allocated again. At that point, the only bottleneck is the network, not the overhead of allocating memory pages. So let's take a look at a pretty concrete example of how this breaks down. So let's take an example of migrating the same active Redis VM. In this case, we're doing a vMotion without shared storage, so we're copying the VM's disk and memory content together. In the first pass, vMotion copies your VM disk state first. So if you're doing a vMotion without shared storage, we copy the disk first, always. Right? We can get into the details of how this works if you like, but at the end of the day, the important thing to remember is that we do the linear cloning of your VM source disk to the destination. This traverses the vMotion network as appropriate. Once we have copied your disk to the destination, we switch to mirroring, just like storage vMotion does. So any I/O that's sent to the disk we've copied has to be mirrored over the network to the destination. Then we move on to copying your memory iteratively. So during this first pass precopy, you can see we do stay around 20-ish gigabits per second, but we end up being bottlenecked here, as I said, because we're allocating memory kind of on demand during this first copy. Once you get to the second precop iteration and the third, bandwidth improves pretty dramatically because we complete that memory allocation and just switch to being bottlenecked on the network. Right? There's no more of this CPU overhead of allocating memory. So this is an interesting kind of, in my opinion, annoying observation about the way vMotion works in 6.0. It's still a dramatic improvement relative to previous versions, but ideally we'd be able to achieve that 60 gigabit throughput and maintain it throughout the vMotion process. And that's something we're actively working toward. But at the end of the day, if you compare this to how vMotion works in any existing environment, this is still very respectable. I mean, I'm personally very happy to see us achieving approximately 60 gig throughput, and we're just trying to continually improve that number as well. So let's take a look at long distance. Right? We've talked a lot about long distance and vMotion Anywhere and vMotion to the cloud, but how well does it actually work, right? So let's take an environment where you've got two different data centers. You've got a vMotion network. I don't believe this was over L3, but it doesn't really matter. L2 and L3 performance should not. The only difference being that your traffic is routed, and therefore your router may be a bottleneck. But either way, we're just basically, in this case now, simulating a long-distance vMotion. We've got these two hosts. We've got a network latency simulator between them, so we can inject arbitrary packet loss, arbitrary latency between these hosts, and we'll perform vMotion across them and see how that behaves. So in this case, we're running a database workload. This is DVD store. I believe this VM was 12 gigs of RAM with 4 vCPUs. Right? So we just want to measure migration time, switchover time, guest workload impact. And fortunately, and interestingly, this graph is really boring. Right? It just shows that as bandwidth, or rather, as latency increases, vMotion performance stays the same. Right? Whether you're doing a vMotion at 1 millisecond latency or 150 millisecond latency, migration time is constant. Right? And that's what we've been trying to accomplish this whole time. Right? As latency increases, it should not affect vMotion performance. So we're very pleased with this slide, actually. It means we've accomplished what we set out to do. And so yeah, duration, switchover time are not impacted by latency. Now, if you look at guest workload impact as well, again, you see very little of interest, which is exactly what we want. Right? vMotion starts. We start, in this case, the start of vMotion, as we mentioned before, is primarily the disk copy. So as you see that little dip when vMotion starts, that's the impact of having to mirror your disk over the network. But other than that, the workload impact is very minimal, right? We're talking, a few percent here. The only really noticeable impact is when you get to vMotion switchover, where we do temporarily have to quiesce your workload, halt its execution for less than a second to switch that execution state, virtual device state, over to the destination host, right? So you do see a brief but observable, if you're looking at sub-second granularity, impact to workload performance. That said, provided you're using anything relying on, say, TCP, this brief gap of unavailability will not be noticeable because TCP retransmit will just ensure your packets arrive successfully at the destination. At the end of the day, there should be no observable application level impact of this process. And that's the goal, right? There just shouldn't be observable impact to someone using this VM. All right, so let's take a little bit of a look at debugging. Don't want to spend a lot of time here, but I do want to just generally share some concepts that may be useful to you just in understanding what vMotion is doing in your environment. So every vMotion has what's called a migration ID. This migration ID is available in the VM kernel logs and also in your VM's logs and the VMware.log in your VM's home directory. You can use this to, say, look at precopy statistics, you can look at precopy bandwidth, you can look at the number of precopy iterations we did, switch over time estimates, page and behavior. This is all in the kernel logs, right? So if you grep in the kernel log for vMotion, you'll see all these different statistics. In particular, you'll see the migration ID, which is this highlighted bit. And we'll get back to that in a second. If you look in vCenter, vCenter lists vMotion as a relocate task. And that's just because vMotion is a way of moving a VM. And anything that moves a VM or its storage is considered a relocate task. vMotion is just a hot relocate. So in vCenter, you can find things like task duration primarily and some data about which hosts the VM was moving between. But given the fact that vCenter treats this operation as a relocate, you can take that observation and look up the relocate task in your vCenter logs, your VPXD logs, if you so desire, and that will give you what's called an operation ID. Operation ID is the operation prefix identifier that's used to track the operation from the perspective of the VPX stack, or the Vim stack, that is vCenter, VPXA, and hostd. So all up and down the management stack, you can search for this op ID prefix and learn about vCenter's interactions with the host, right? And there'll be some statistics there as well. For example, switchover time will be present in the hostd logs, as well as it's available in your VMware logs. An interesting thing here is that given the migration ID or the op ID, if you look at the hostd logs, you can see the correlation between the two. Both of those IDs will be present in the same log lines in the hostd logs. So if you so desire, you can use this to navigate our log and just kind of dig more into what vMotion is doing in your environment. Personally, I think the kernel logs are the most interesting because that's where you'll see statistics about vMotion network bandwidth, right? So if you have concerns about performance, you can take a look at your kernel logs and see, oh, I wasn't achieving the bandwidth I expected. What might be wrong? Right? And you can kind of dig into that. The other interesting thing that Nicole briefly touched upon is this thing called stun during page send. I don't know how many of you are familiar with that, but the idea is if you're doing something like iterative precopy, right? You're moving a VM between two different hosts. You're copying that VM's memory changes over a network, right? And the network has some throughput. Let's just, for the sake of argument, say it's a 1 gig network. If you're running a really, really active VM that's dirtying memory more quickly than your 1 gig network can send it, meaning we're falling behind in iterative precopy. We do a pass, the VM has dirtied more memory than we sent in that pass. We try to do another pass, we're not making progress. We're actually falling behind. We have to take corrective action or we'll never be able to move that VM, right? So SDPS, or stun during page send, is our technology for slowing down a VM's guest execution just enough to ensure that we can switch over successfully from source to destination. We do this by observing our achieved vMotion network throughput and monitoring the VM's dirty rate, the rate at which it's changing memory content, and injecting microsecond delays into the VM's execution such that it doesn't stop your workload. It just disrupts it enough to ensure vMotion precopy can converge and we can switch over. So if you're ever worried that vMotion is impacting your VM performance, if you look at your kernel logs, you will very clearly see whether or not SDPS, or stun during page send, actually had to activate, right? And if it did, that means the VM's too aggressively dirtying memory for your network infrastructure. So you can improve that by either having a less active VM, which is kind of hard to accomplish unless you want to take some sort of downtime or move workloads internally off of that particular VM, or more reasonably, I think, you can scale out your vMotion network infrastructure. So if you only have, say, 1 gig NICs, switch to 10 gig NICs. If you only have 10 gig NICs, or you have a single 10 gig NIC, try multiple 10 gig NICs, right? With 6.0 at least, we'll be able to more than leverage, say, 3 or 4 or 6 10 gig NICs, right? Okay, so with that, let me switch back over to Nakul, who will talk about what's coming next for vMotion.
Thank you. So what's next? Like I had said before, the second theme that we were going to talk about was the cross-cloud vMotion. And this is one step further ahead in our theme about doing vMotion anywhere. So here, for now, we've chosen the cloud to be vCloud Air, and it could be any different public cloud at some point, maybe. And the other aspect that I was going to highlight here was you don't need to upgrade to vSphere 6. We have backward compatibility with 5.5 as well. So those were the main two things about the cross-cloud vMotion. The next thing that I was hoping to touch upon was NVM, the non-volatile memory. So thus, this resides on DIMM, and it has, the interesting part about this that we are quite keen about was about the fact that it has nanosecond latency access. Now, why this is important is this is way faster, or like several magnitudes faster than even PCIe flash. So that helps enable or do vMotion much, much faster. So that's something that we are quite keen about going forward. Finally, the active-passive storage replication. I know a lot of you folks have quite a few of these partners, storage partners in your data centers, and helping make this possible would be a lot beneficial to you. We've heard that from a lot of customers and from you folks. So yes, this will probably be the next step, and vMotion support for RDMA as well. So those are the few things that we're looking forward to for vMotion in the next few months or the future roadmap. Finally, just to outline what we discussed today. Again, the top 5 features for vMotion in vSphere 6, starting with multi-switch, then we're going off to across network, then crossing geographical boundaries, management boundaries, geographical boundaries, and then replication-assisted vMotion. Those are the 5 main features for vSphere 6 vMotion. We did touch upon a few performance and debugging topics that Gabe shared with you about. And finally, looking forward, we're continuing with our theme of vMotion anywhere with cross-cloud vMotion. With that, we're open for questions. Gabe, if you want to come over. And do fill out the survey so that we know how you like the session.
Are there mics? Yes.
Thank you. Just a question. I was quite surprised during the presentation that you didn't talk about eventually NS6 integrations with vMotions today. And the main question is because today one of the problems we have on vMotions is the interlane network, meaning that the configuration is missing somewhere, and we can move the VM, but we unfortunately can lose access to it. So the only way to do is a rollback mainly. So do you have any plan regarding that point?
Absolutely. I mean, I'd be curious to understand more about your network environment in particular. NSX in general is entirely compatible with vMotion. It's possible in your case there's something interesting about your configuration that's causing us not to observe that the configuration is not present at the destination.
Yeah, it's probably a human mistake, I mean.
Maybe, yeah. It'd be great if we could sync up. Maybe, I don't know if you can send me an email or something, but that absolutely should not happen, right? The whole point is that you're supposed to maintain network connectivity during vMotion, and certainly today we're testing NSX integration with vMotion. We have historically as well, though, so it surprises me that that's an issue for you.
Well, mainly, I mean, it's if someone missing configuration on the switch, for example, missing a VLAN on the remote site, okay? So the vMotion today is not able to detect it. So you will have, of course, you can have your in a distributed switch environment. You can see the POG group configured on the vCenter. So VMware will not detect it, but on the underlying networks configurations, you know, the access to these virtual machines can be a problem.
Sure.
So the only way to the guys is just make the rollback. So the question is regarding the NSX today integration on the overlay network. Are you planning to do in-deep integrations to be sure that the network is well configured from end-to-end point of view?
That's an interesting point. So, I mean, historically, as you know, we have not, right? The assumption is that the underlying physical network has been configured appropriately, and then the distributed switches and the switches you build on top of that, from vCenter's perspective, span those in however you define, right? So we trust that you did the network, the physical part correctly, and we handle the virtual part and validate at the virtual level. Point taken, though, with NSX, we have much more insight, right? If you're actually using NSX to manage your physical infrastructure as well, we could validate that you've done all that correctly. That's a really good point, and definitely an opportunity for better integration. So it's a little hard to see, but...
No, there is one there.
Oh, great.
With all these new types of vMotion, will they be presented in the vSphere API, or are they going to be integrated into the vCloud SDK and have kind of a split APIs, which seems to be happening with a bunch of the newer features for vSphere itself?
So it depends which flavor of vMotion you're talking about. All of these are built on the vMotion existing API in vCenter called relocate. Right? All of these are just another flavor of relocate. If you're doing a vMotion across, for example, distributed switches, that's a relocate where also changing the network backing of a given network interface. So if that's our existing API, you just have to also specify, oh, I want this network backing to change from DVS-A to DVS-B. Now, if you're talking vMotion to the cloud, that's a different story and is actually more future-looking. That would be a different API because that's an API against vCloud Air as opposed to against your vCenter. So there is a different API service for that one. So, questions? I think there's a question back there. No, maybe not.
No.
Okay.
Right.
All right.
Thank you.